Hello and welcome to Upstream at AKS, the series where we dive into how we're building cloud native experiences in the open source community. Thanks for being here. My name is Lachie Evenson, and I'm a product manager on Azure's cloud native ecosystem team, where our mission is to help make the community successful on their cloud native journeys. We have an awesome team that you'll find in almost every part of this ecosystem. And today I'm happy to introduce my colleague, Ernest Wong, who is a member of our Upstream team. Welcome, Ernest. It's great to have you here.
Thanks for having me, Lachie.
Please tell us about what you do at Microsoft and in the cloud native ecosystem.
Sure. I've been contributing to the cloud native ecosystem open source community for almost 7 years. I'm a software engineer at Microsoft, and I've worked on different projects like Kubernetes test infrastructures, as well as Gatekeeper. And recently, I've been leading a project called Kubernetes AI Two-Chain Operator, or Kaito, and it's been a lot of fun.
Oh, okay. So you're in the heart of kind of this AI revolution in the Kubernetes ecosystem, which I'm sure is a lot of fun. Tell us about a little bit more about Kaito and what the problem it seeks to solve.
Sure. So Kaito is a Kubernetes operator that automates large language model deployments to your Kubernetes clusters. And it also has things like tunings and retrieve augmented generations. So some of the key problems that Kaito is solving are things like we want to address the complexity of deploying large language model to your Kubernetes clusters by providing a really streamlined and container-based approach that eliminates the traditional challenge of virtual machines-based model deployments. And one of the main features is Kaito manage large model files using container image with
Mm,
OpenAI compatible inference APIs. Our main inference engines include VLMs and Hugging Face transformers. And Kaito also automatically provisions GPU nodes on behalf of the users based on the model requirements, like how much memory the model is consuming.
mm.
And we're also going to take that information and calculate the optimal VLMs or transformer options for the users to maximize their GPU utilizations.
Okay, excellent. I mean, there's a lot going on here, Ernest, so I'm going to kind of break down what I heard. So when you're talking about LLMs, large language models, obviously, what are kind of the constraints that they need to operate in if you're saying deployment is challenging of LLMs? Why is it challenging? Obviously, it's large, so I'm guessing it needs a lot of resources, but
Mhm.
what kind of challenges are there in deploying LLMs on Kubernetes?
Yeah, Kubernetes is great for deploying things like web app. It provides a really nice declarative patterns for users to deploy what they want. But for things like large language model, it has a lot of things to consider before we deploy it to to Kubernetes clusters. First of all, you need Kubernetes nodes that has GPUs, because GPUs would accelerate a lot of the calculations when we're serving large language model. So that's the first piece. And the second piece is finding the optimal uh, inference configurations.
Mm,
So if a user creates a Kubernetes deployment that targets a GPU node in your clusters, there might be problems like out of memory errors, where users might have to test a couple of configurations in order to serve their large language model. But that's where Kaito shines. Kaito automatically takes in users' model and the model's memory requirements, and it will provisions the right GPU nodes for the users. And if users want to provision a GPU node without sufficient GPU memory, it'll also throw an error. So it has this fail fast patterns so that the user knows exactly what's wrong with their inference configurations. And another challenge is calculating GPU memory requirements for a large language model is very difficult, because there are a lot of open source large language model out there, and it's super hard to have a generic formulas to calculate how much GPU memories a certain models needs. And that's where Kaito comes in and help the users calculate those configurations and give the users a very nice optimized configurations to serve the LLM successfully on the Kubernetes clusters.
Okay, so Kaito really helps with getting the right infrastructure at the right time to be able to serve, those LLMs and the inferencing workloads, which I think is great. You mentioned something else and when you were describing Kaito about container images as well. How do containers fit into this whole, platform in Kaito?
Yeah, so large language models contain several files, things like state tensors, which is the files that contains all the weights of a large language models used to calculate the inference results. Those are usually very large files, and currently the industry standard is that we download directly from model registries like Hugging Face. But Kaito's approach is a little bit different. Instead of having the user download models from Hugging Face or any other remote model registries, we actually help package the models and all the necessary files into a container image as an OCI artifacts so that we can upload it to a secure remote registry for Kaito to download the models from. And in addition to that, we also run end-to-end tests for all the models that we support. So users who are using Kaito's preset models, we package all of them as container image and OCR artifacts uploaded to the remote registry, and Kaito will pull it down on behalf of the users. And the users have the peace of mind that all these model artifacts and OCR artifacts are all secured, scanned, and all tested before we release them.
I think that's really neat that you're able to reuse container registries to store, large language model weights and be able to use that as distribution as well. So I think that's neat that you're able to take a tool that was built for something else and repurpose it for this use case. You also mentioned something about Kubernetes, in being great for web apps. What makes Kubernetes a great platform to do, AI inferencing and run Kaito on?
So by building Kaito on top of Kubernetes, we can leverage the Kubernetes extensibility. Specifically, Kaito follows the Kubernetes operator design patterns where we have custom resource definitions within Kaito for users to define what kind of models they want to deploy. So instead of having the users to write raw Kubernetes deployments to deploy their large language model, which can contain hundreds of lines with all the configurations, Kaito offers a very simple way and simple custom resource for the users to define what they want and basically the desired state of the large language model serving
Mm.
service. So they can leverage Kubernetes declarative approach and deploy that custom resource to their clusters, and the Kaito controller will handle everything for them, including GPU nodes provisioning and writing the correct deployment YAML and deploy it to the Kubernetes clusters on behalf of the users. So the users don't have to worry about, if this VLLM flag is the correct one, or if this is the correct value or not, because Kaito is aware of all the optimal flags, and we also have our own methods of calculating some of the optimal values for certain flags in order to maximize the GPU utilizations. And also the overall Kubernetes ecosystems, right? So things like device plugins for NVIDIA GPUs allows
Mm.
Kubernetes workload to claim GPUs from the worker nodes. So comparing to the traditional virtual machines-based model deployments, where you have to install your own NVIDIA drivers and use Docker to run your models, we can leverage the existing rich ecosystems of Kubernetes. So things like GPU operator to help automate the GPU installations and upgrades, as well as existing device plugins to help seamlessly integrate the whole Kaito experience into the Kubernetes ecosystem.
Excellent. I love that, Kubernetes is such a versatile platform that you can modify it to run AI workloads. And as you said, you connect into an ecosystem of tooling that you already have, likely have in your infrastructure. So one other piece that I heard in your intro to Kaido is fine tuning. Can you talk me through fine tuning and what that involves and why you need it?
Sure. So normally when users deploy a large language model, they're trained by a large amount of data, a large amount of public data. So things like the llama 3.1, 8 billion, or the Microsoft 5.4 models, they're all trained with a large amount of general public knowledge from websites like Wikipedia. But when users want to have a really specific large language model that excels in certain things, like answering medical questions, then the normal generic models might not work because they might not be trained with a large amount of those really domain-specific data. And that's where fine-tuning comes in. Fine-tuning involves taking data sets with the data that you want to train your large language models and fine-tune it so that in addition to all the general knowledge that it also has knowledge on the domain-specific data that you want the model to train. So that's where fine-tuning comes in. And in terms of fine-tuning on Kaito, we also support container-based fine-tuning, where the user package their training data, and you use the Kaito's custom resource to specify the data locations. It can also be a Hugging Face remote data set, and we have services to fine-tune a specific large language model that we support with those data. And the output of that fine-tuning job would be what we call an adapter. So adapter is something like a USB-C cable, where you have a large language model with USB-C port, and then you plug in those USB-C adapter to your large language model. So now your large language model not only can can answer general questions or be your day-to-day chatbot, but with the adapter's knowledge, it can also answer domain-specific questions that you provide to the fine-tuning jobs. So for example, using the previous example, if I want to fine-tune a public large language model with domain-specific knowledge like medical knowledge or even X-ray results, right? So these might not be trained very well in the foundational model, but having a lot of data on specific areas would actually help the large language model learn better. And with the adapters, you can switch between the foundational model and the fine-tuned model to answer specific questions that you like.
Excellent. This is a really interesting topic. Thanks for walking me through it. So really, fine-tuning is about your domain-specific data, and you have an LLM, which is likely a foundational model. And as you said with your medical example, you'd be taking a foundational model, which it likely doesn't have maybe the latest information or specific results about specific tests. And then you can connect that into the LLM. And then when you're asking an LLM to inference, it has access to that data that's domain specific. So, I can think of other things like documentation or other bits and pieces where you really want to have up-to-date information that's actually rolling in on a cadence, get into the LLM so that as you're prompting it, the inferencing is up to date. That's really interesting that Kaito supports that, and I imagine that to be a standardized pattern. Now, Ernest, we've spoken through Kaito. I think we've been through quite a few pieces here. I always like to ask, what are you most excited for the future of, the space that you're working in either Kaito or AI on Kubernetes?
Good questions. I think I have two areas that I'm most excited about. The first is retrieval augmented generations, which stands for RAG. So in addition to fine-tuning, there are also different ways to give context to your large language model, because large language model is confined to the amount of data that it trains, right? And then there's a knowledge cutoff date for those models. So having the ability to read documents that is not part of the training data set is going to be super valuable in terms of giving enough context for the large language model to generate a meaningful response. And that's what RAG comes in. RAG supports, allows users to upload PDF files, Word documents of their own It could be private. It could be the latest and greatest spec of a specific products they found online, and feed it into a LLM and ask specific questions about the document. And that's what RAG is about. And I'm also super excited to tell everyone that RAG is also supported in Kaito as a custom resource. So in addition to the serving, like inference service that Kaito supports, we also, on top of that, we support RAG, which is a custom resource within Kaito that automatically set up the whole RAG pipeline on behalf of the users. So users don't have to worry about all the details of how to deploy a RAG. And the RAG engine underneath is consists of a couple things. So the vector database for the embedded documents, as well as a large language model that is connected to the vector database. So when the user uploads certain documents to the database and send a query to the large language model will be able to query that vector database, find relevant information on your documents, and use that as context and generate a more meaningful response to users. So that's what I'm really excited about. And the second thing is agents. I'm super excited about agents because it allows users to define their own agent workflows to do things that they want. Because large language model can be great for chatbot applications or day-to-day Q&A applications. But in order to leverage the large language model capability, I think agent is an area that I'm super excited about, because all agent is about is using large language model as the brain to interpret a complex questions and break it down into step-by-step solutions on behalf of the users. So things like coding, GitHub Copilot uses LLMs to understand the user's queries and break down the problems into line-by-line, step-by-step solutions. And also, agent use a lot of tools, external tools like fetching external websites, which is also just enriching the response by giving the large language model more context. And that's the ultimate goal, is to generate a meaningful response.
So, Ernest, clearly you're passionate about this space, and that's conveyed to me, and I'm getting really excited about, AI and Kubernetes and what Kaito can do. Where can folks who are interested about Kaito actually get connected in?
Yeah, so we have an open source GitHub repository called Kaito under the Kaito project's GitHub organizations. So that's where all the open source contribution goes in. We have weekly community meetings where we talk about the next milestones, what we're trying to solve, as well as answering any community questions that the contributors might have. So that's both places are great for contributors to start looking into Kaito.
Well, it's been great having you on the show, Ernest. Thank you for all your time and sharing all your knowledge. I think we're going to have you back just to discuss a little more about agents. I think you gave us a little tease into the world of agents, but we didn't quite have time to go through all of it. So I really appreciate you being here. Please like and subscribe, and don't forget to let us know about what topics you'd love to discuss on the show in the future. Thanks for being here, Ernest, and thank you, everyone.
Thanks.
Bye.